Hello and welcome. I am Shanu Tripathi, and in this lecture I am going to discuss about data transfer instructions of 8085 microprocessor. First we will see what is an instruction. An instruction is a binary pattern designed inside a microprocessor to perform a specific function. Entire group of instructions supported by 8085 microprocessor is called instruction set. Each instruction has two parts. The first part is opcode, also known as operation code, and the second part is operand. Opcode is a task or an operation to be performed, while operand is data to be operated on. Let's take an example. Suppose we are intended in moving the content of register C to register B. So moving will become our task or operation, while register B and register D will become our operand. Now we will see the classification of 8085 instructions. So the whole instructions of 8085 are broadly classified into 5 functional categories. The first category is data transfer instructions, the second is the arithmetic instructions, the third is the logical, the fourth is branching, and the fifth is machine control instructions. In this particular lecture, we are discussing about some of the data transfer instructions. Data transfer instruction copies the data from source to the destination. The content of the source are not modified while copying, and these instructions do not affect the flags. While discussing about the instructions, we will be following certain notations. The first is R. R is a 8-bit registers of 8085. They are A, B, C, D, E, H and L. RP is register pair. We are having 3 register pair. First is BC, the second is DE, and the third is HL. BC pair is denoted by B, DE pair is denoted by D, and HL pair is denoted by H. SP is the stack pointer. M is the memory location specified by the content of HL registers. Now the first instruction which falls into the category of data transfer is the move instruction. The mnemonic is MOV. This instruction is having the 3 variant. The first variant is RD, RS. So here D and S are destination and source respectively. The second is M, RS, and the third is RD, M. M, which is the one of the operand in second and the third variant, is the memory location specified by the content of HL register. These instruction copies the content of source register to the destination registers, and the content of the source registers are not modified. Now we will see the example of this instruction. The first example is MOV D, B. So this instruction will copy the content of register B to register D. This clearly represents that this belongs to the first variant RD, RS. So B will become my source register and D will become my destination register. Let's take B is having 2F. Right now I have not drawn what does D contain initially. Let's take I am not having any information what D contains. So after the execution of MOV D, B, the content of B will be overwrite to the content of the D. So D will be having the content of 2F, which is the content of B. Now the second example is move M, B. In this example, we are intended to transfer the content or copy the content of B register to the memory location. Now what is the memory location? The content of HL register. Suppose my H contain 20 and L contain 40. So HL register pair content will become 2040. So the content of the B will be copied to the memory location which is pointed out by HL pair, that is 2040. So what it will do? So 2040 will have the content of B register. What is the content of B register? That is 2F. Next instruction is MVI instruction. It stands for move immediate. It is having the operand S, R as well as M. This instruction will copy the 8-bit data in register or memory location. So let's take an example. So if I write MVI A, 23. So A is the example of R. So I am intended to load this 23 in my register A, which is also known as accumulator. So if I'll go and check my accumulator, I will find 23 in that. This H stands for hexadecimal base. So 23 is in hexadecimal base. Now MVI M, 1E. This is the second example. So what I am intended to do, I am intended to write this number, that is 1E, into the memory location. So what is the memory location? It should be pointed out by HL pair. So let us suppose the content of H register is 20 and the content of L register is 30. So the content of HL register will become 2030. So 1E will be written at 2030. So 1E present at 2030. The next instruction is LDA instruction. This instruction is load accumulator direct. Operand is a 16-bit address. The content of the memory location specified by a 16-bit address in the operand are copied to the accumulator. And the content of the source, what is the source here? We are copying the data from the 16-bit address. So the source will become the memory location, are not modified or altered. So example is LDA 2055. So this is my 16-bit address from where I am intended to load my accumulator. So suppose 2055 contain F8. So after the execution of this instruction, my accumulator will have F8. So this F8 is copied to the accumulator, that is A register. Next instruction is LDAX. This is known as load accumulator indirect. This instruction is having B/D register pair as an operand. This instruction copies the content of the memory location specified by the designated register pair. What are the designated register pair here? Only B as at D register pair. We cannot use the HL register here into the accumulator. So the content of either memory location or the register pair are not modified. So let's take an example, LDAXB. So what we are intended to do here, we are trying to load our accumulator with the content which is present at the memory location specified by this pair. B stands for BC pair here. So BC, suppose my B contain 20, C contain 10. So the BC pair location will become 2010. And let's take 2010 is having 12 here. So my accumulator will be loaded with the content which is present at 2010. So after the execution, if I'll go and check my register A, I will find 12 there. Next instruction is LXI, load register pair immediate instruction. This instruction is having the operand as register pair as well as 16-bit data. This instruction loads 16-bit data in the designated register pair. We have seen in the earlier slides that register pair could be BC, DE and HL, and stack pointer also. BC pair will be denoted by B, DE pair will be denoted by D and HL pair will be denoted by H. So if I am writing like this, LXI D 2052, what does it mean? D means I am talking about DE pair here. So 2052. So my D pair D, basically D register will be loaded with 20 and my E register will be loaded with 52. Now moving to the next instruction, that is STA instruction. This instruction stands for store accumulator direct. This instruction is having 16-bit address as an operand. The content of the accumulator are copied to a memory location specified by the operand. This is just the reverse of LDA. So if I write STA2500, what does it mean? I am storing the content of my accumulator to this particular memory address which is given in the operand. Suppose my accumulator is having 2F, and if I write 2500 as a 16-bit address, so at 2500 the content of this accumulator will be stored, that is 2F will go to this location 2500. Next instruction is STAX, store accumulator indirect instruction. This particular instruction is having B/D register pair as an operand. This instruction copies the content of accumulator to the memory location specified by the content of the designated register pair. And what are those pair? B/D. So STAXD, what I am intended to do here, I am trying to store the content of my accumulator at the memory location which is pointed out by DE pair. Let's take my accumulator contain 40, my DE pair contain 2010. D contain 20, E contain 10, so DE pair contain 2010. So if I'll write STAXD means the content of the accumulator will stored at the memory location pointed out by DE pair, that is 2010. So 14 will be stored to the location 2010. So that's it for this lecture. Thank you.